Recording in progress. Recording stopped.
Okay, so let us start. Now, today we will be starting our discussion on the operating system. And the basics we will discuss today and about the process, right? So, previous day we had ended our discussion on the software engineering. Now, again, if you have any question, you can always ask me through WhatsApp or something, or what you need to study, those things you can ask. As you have required those questionnaire and everything, those I will post. Okay, in due time, within this week only, I believe I will post, right? Now see, the first thing today we will be discussing is what is an operating system, what exactly is present there, and what do we require out of the operating system, the basic introduction. And we have 3 allotted classes for operating system, and hence our discussion will be stipulated towards the question answers, or the topics from which you can get the questions from, right? Okay, some people are giving attendance, so just let me remind you, no need to give attendance in these classes. Your attendance will be automatically calculated from your login, right? Okay. So first is, what do you mean by an operating system? Now, okay, so points I will be writing, and I hope you will also be following those points. Okay. So if you have pen and paper with you, you may note down the points so that later on you can have a look at them. So our topic of this discussion for today and the next 2 classes will be operating system. And today we will be discussing on the basics and process. So there are more or less 3 to 4 important things in an operating system syllabus. One is process, one is memory, and one is the storage, that is the file. And other part is the protection and security. So from all the parts, we will cover the questions that can be asked from, right? So first thing first, what do we mean by an operating system? What is an OS? Now, you have already learned software engineering, so you already know what is a software. So first we will be understanding what is a software. See, your computer is a hardware device, right? And you as a person directly cannot always operate on the circuits, right? Again, people who are giving attendance, please don't give, because we don't require attendance in these classes. Your attendance will be automatically calculated from your Zoom account, right? We will use the chat box for question answers only. Don't give attendance. Now, you being a human being to an hardware device, you cannot always use wires and like ICs and other things to communicate, right? So our goal is to facilitate the process of calculation or like programming or interaction with the system, not to find out or not to just make ourselves more loaded, right? So in this particular case, we require an interface where we can type and do our work, right? So we require an interface. Now, our software is the one who is giving us the interface. Mainly we use GUI or we can use CLI. Now softwares again can be of two types. One is the application software and one is the system software, right? So when we talk about application softwares, these are the things like, suppose this Paint. Paint is an application software. You use, suppose some gaming consoles. Those are application softwares. Something which you are utilizing for doing some work, but it is not involved directly for hardware communication of your system is the application software, which users friendly things that you use. And what is system software? This one is the permanent portion which every time when you switch on your system will be loaded and will be using. Suppose your mobile phone, you are switching on your mobile phone and you are working, right? Every time when you switch on, do you need to install every app? Do you need to install your phone contacts and those things from any other device? I don't think so. So system software is that, application software is any app that you are using. Like Paint right now I'm using, that is an application software. MS Word you are using, any audio softwares you are using for listening to music, watching movie, those things, those are application softwares which users are using. And something which a system is using, that is a system software, right? So as I was telling, the platform that is provided to you on which you are working, the platform that is provided to you on which you are working, that platform is your operating system. So you as a person who does not know, suppose anything about hardware, but you need to type something or suppose click on somewhere and do some work. This screen that is provided to you or the user interface UI provided to you is done by operating system. Also, operating system is managing all the resources that the hardware is having. Suppose input devices, output devices, the memory device, all of you have learned COA, right? So you know what are the components. So these are also managed by operating system. So what basically being a like general definition or explanation for operating system? A program or a set of programs which is enabling the user easily, or you can say to give a better working environment for the user, not directly communicating to the hardware, is given by the operating system. So every time when you switch on your mobile phone or you switch on your laptop, every time you don't have to install every app present, or you don't have to think about where you will store, so how much memory is left. These things you don't have to bother about, right? So these are managed by your operating system. Fine. So this is the basic fundamental thing about operating system. Now we will next, we will be moving towards the GUI and CLI. GUI is the interface which is graphical user interface. Means you have icons on which if you click something will happen. This is graphical user interface. And command line interface is you have to write commands to execute your work, right? So that is command line interface. So basic examples can be your Windows and Unix, right? Now Linux can have different versions. Some are GUI, some are CLIs, right? So better see in the normal syllabus or in the labs, you go through Linux because Linux or Unix, because those are difficult to handle, right? But Windows is very easy to handle, but that does not mean that Windows is excluding from your OS. Windows also has got different versions. Some are obsolete, like Windows XP generally we don't use, right? So nowadays we use better versions of Windows. So that is a perfect example of GU. And CLI are those which is difficult to use. You have to write comments and you have to use. Fine. So this is your application software and system software, and your operating system is a part of this one. Right? Your operating system is holding this one. Now, then what idea we have learned? If this is you, this is your OS, and this is your computer, like the hardware. It can be computer, it can be any other interface, right? So this is your situation, right? So direct hardware communication is a bit difficult. Hence, we go through an interface, right? Which can control or communicate to other resources present. Fine. So OS works as the resource manager. What resources it is managing? I have given few examples. So these can be the resources that it is trying to manage, right? Also, OS is your resource planner. Now, when we will study process, we will understand every work that you are doing is a current ongoing process, right? So for that, which particular device is required or which particular device is ideal, these things will be decided and scheduled by the OS. Fine. So suppose you are typing something on a Word doc, you are listening to some audio, at the same time you want to serve some web page. So the order will be done by the OS, and this comes under your resource planning. Fine. So we can say that OS is providing you the platform, right? It's a very common term, platform, on which the application software, or I can say apps, run, right? So this is the key point that all of you must remember, right? Next, if I go to your, like, where exactly the OS is lying, if I go into that, then the most core part of your system is the hardware. After that, we have the kernel, right? Then we have the shell, and then we have the application program, right? Or you can say the user. Fine. So your hardware is directly being communicated by kernel, and then the kernel is communicating to shell. That means kernel is your connector point. Now you can ask that, is my OS is same as my kernel? OS and kernel, they are same? No, they are not same. So what is kernel? Kernel is a set of programs which is loaded at the time of booting. What is booting? When you switch on the power machine, my power switch, some things are automatically getting loaded by in your system, and along with that your OS is getting loaded, right? So kernel is those set of program which, when it is getting loaded, is the first program which will get loaded when your memory, like how much free memory is there, what is previously stored in your memory, like you have some secondary memory, ROM, those things, right? So your operating system is lying on your ROM, right? So those things are, those drivers are set. So that is kernel. And what is shell? Shell programming you have done. So shell is the interface where you write your commands and those things. Like for Linux or Unix, shell is those platform, that platform where you are writing all your input or your comments, those things, right? And what is the application program? This is the high level or the high end users where we will be giving instruction, right? Can you please repeat the work of kernel? Yes, kernel is the one who is interacting with the hardware. That means when you switch on the power, like power switch, you are switching it on, then the first set of programs, that are being loaded on your hardware like memory, on by which your printer starts working, your memory is activated, the OS is getting loaded to your memory. Those things are done. That driver is your kernel, right? So kernel is not a hardware device. It is your program. It's just a program which is the first, which will get first loaded to your machine, right? So this one is the layered view of what is present in your computer. Okay. So this is very important because you may be asked for what is the difference between kernel and last set of program, first set of program. Why last set? One person is asking last set of program. I did not get your question. The first set of programs without which your means nothing can be done on your system. Previous work has to be loaded. That is your kernel. Shell is giving you the interface where you can write some direct comments by which your system can work. Not application program, not apps, but direct program. Shell programming you have done, I believe. Those who are having, those who are CSC students, means computer science students, they have done shell programming, right? So shell is that particular interface where you can write direct comments. Like suppose you can write driver comments, right? Or you can write comments like to change mode, ch mode command, to change the mode of a file operation. You can use grep for search operation within a file, right? So operations or comments, if time permits, we will discuss, or else I'll just give you in a nutshell what comments generally we use, right? So this is your layered view. Next question that you can face are the goal of the operating system. The primary goal is to give the user convenience. Means easy to use, right? To give the user the convenience to use, so that Windows is more popular than Linux. Any GUI will be popular than your CLI, right? And what is the secondary goal? Secondary goal means, primary goal means this user can directly view. Secondary goal is for system. So how efficiently your system resources can work. How efficiently your system resources can work, right? So what it means, suppose I have memory, right? So maybe all of you will have the notion of cache, right? Cache memory. So why this is used for? From your primary memory or main memory, whatever you call, if I can copy some data in the cache, then cache can directly communicate to the hardware. So whenever hardware is free, we don't invest the time of primary memory to search and supply the data. Cache can directly do that, so that we are involving cache, right? So when I will use cache, when I will use primary memory, these decisions are to be taken by the operating system, right? And this is the secondary goal, that I can make efficient use of my system. So gradually we will learn process synchronization, we will learn process scheduling, we will learn memory management. So there you will understand that how your operating system programs are dividing the task, like making the work into multitasking environment, right? So with this, the functions of your OS, first, process management, main function. Next only I will come to what is a process and so. So process management. Next is memory management. These two are utmost important. Without this, you cannot do anything. Next, we'll come to the optional ones. First is the IO management, IO device management. IO device means input-output device like printers, scanners, those things. Those are optional, obviously. When I require, I will use them. Next, I have files. So file management. If I have, if my machine is situated on any network, Then network will be used. So network management and privacy and security, because every data you cannot send over the network, right? So these are more or less the work or the functions of your operating system, right? So every stage we need to study, but that much time is not there. So let us see how much we can. Now, so what questions we have studied till now? Number one, what is an OS? Number two, what type of softwares do you find? Number three, OS is doing exactly what? That is providing the platform. Number four, this layered architecture. Next is what is kernel, what is shell, what is application program. These three things. Next, goal of your OS means why we will use OS, and the function of the operating system. Right. So this much we are done with. Next, type of OS. Types. So here we will study few names. Some are obsolete, some are used now. There are different versions, so we will just go through them once. First one is the batch OS, right? So what is a batch OS? Previous days, how we had worked, we had programs like a job where the programming part was there, the data items were present on which the program will run, and some control instructions. Control instructions were present. And we submit the job, and the job will do some work and show us the output. Now suppose if this type of system we think, we can think of mainframes. So what was done there? We take input from the user, then we prepare a file, suppose a calculator. So the values of A, B, C, suppose we feed. What are the like operations that I can do, like plus, minus, logarithm, division, multiplication, those things I can take. And the control instructions, that is, if I click or if I want this, then addition will happen. If I want that, then this thing will happen. These things will be there. So I will club all things together and I will submit it to my processor, right? Likewise, job 1, job 2, like n number of jobs can be submitted at a time. One by one, each job will be taken up and completed its work, right? And at the same time, this will be displayed on your output device, right? So this was the previous concept when we are used mainframe. But what is the problem? Here the main problem is we cannot interact with the user. Interaction is not possible. Interaction is not possible in this particular scenario. We need to take previous data and we need to store, right? So our work has shifted to the batch processing, like user 1 is submitting job 1, user 2 is submitting job 2, and likewise. Then every job is submitted to your operator, right? Based on this, similar job means suppose IO jobs, those who want to take input, those jobs, or suppose some which are doing only calculation, that is a set of job. So likewise, they prepare batches. Understand this concept? Operator will prepare batches, like suppose batch 1, batch 2. Batch 1 is suppose having all the IO jobs. Batch 2 is suppose having all the calculation job. And likewise, in number of jobs are prepared. That will be submitted to your computer. That will be submitted to your computer. So what is the computer? Computer is the processor, CPU, along with the operating system and the memory device, right? OS plus memory, OS and your memory together, right? So this is your computer. This will produce the output. So this particular work is named as batch processing. So my job is modified into batch. How? Similar working jobs are taken together and they are being made as a batch, right? If I say, suppose I want to take input, so my input job, so batch 1 is suppose my data input job, batch 2 is suppose my suppose you can say scanning job. So all the scanning work of your processor will be taken together. Likewise, n number of jobs. So at a time, the processor will take one batch, finish all the work. Suppose it takes the input batch. So all the programs that require user input will be taken at once and will be stored in the memory. So I'm writing here OS plus memory, right? So this is your concept of batch processing, right? So like we can give examples as Fortran, COBOL, these things use batch processing. So mainframe work only is modified and it is being used as batch processing. Okay, so this is your concept. Like now again, advantage, disadvantage, you have to study. Advantage is the job processing is done one by one, right? So the compilation time is reduced. Compiler time is reduced. Now, what do you mean by that? See, if I take scanning job, then the instruction for a scanner is same for all files. So only one time it is compiled and every file is getting scanned by that. Suppose I have scanning in 5 programs. Now, if I do it individually, then 5 times I have to execute the scanning instruction, right? So that compilation time, if I use batch processing, is being reduced to a lot. Fine. And it's a fast process also, we can say, but that I don't think is a big advantage. So compilation time only we keep in advantage. Now, what is the disadvantage, or should I say the scope of improvement in your batch processing? The memory utilization. Now see, this is the first one, and second one is priority. In batch processing, we are not doing any priority basis work. Batch processing means all the work which are same or similar type of IOs are using, or similar type of components, resources are being used. Those things are being worked at a stretch. But what if all of them are not very much important at a particular given time? So priority is not monitored in case of batch processing. And what do you mean by memory utilization? Suppose I am taking inputs. So all inputs that I take will be stored. So my memory is used much. If suppose I have 10 programs and one by one I was dealing with them, then not using batch processing normally, then one time the input will come, it will be used, and then it can get deleted or transferred to secondary memory where I am not using it anymore. But in case of batch processing, you have to take all inputs at a time, right? So that can be the disadvantage, right? Next we will go to the multi-programming operating system. Next type, multi-programming operating system. Multi-programming operating system. Now, what is this one? Suppose P1, P2, P3, P4. 4 programs. Now, before this, you must understand what is a process, what is a program. I have also told this before, I believe, just to revise. Program is a set of instructions that is stored in your memory. When you are executing them, they become process. Suppose you have an application, but you are not using it on your mobile or laptop anywhere. That is a program. When you are double clicking on it or clicking on it and start using it, it becomes a process, right? So suppose I have 4 programs P1, P2, P3, P4 in my processor. When my operating system is working on P1, suppose it is working, at a particular time, it is waiting for my IO device. Suppose without input, it cannot work, right? So it is waiting for my IO device and not utilizing my processor. Waiting means what? Not utilizing my processor. At that time, I give P3 a chance to work. So understand the concept of multi-programming OS. When there are multiple programs ready in the processor for running, like in ready queue, we call that as ready queue, means all are compiled and they are ready to execute. When one process is going into waiting state for any work, that can be IO, that can be any other type of work, computation work, anything, means it is not using processor, we will give the chance to another processor for execution. And like this, CPU utilization is more. CPU utilization is more. So CPU is not idle at a particular time, right? So this is your multi-programming system, right? So if this is the case, then the advantage is your CPU utilization. What is the disadvantage? Disadvantage is the scheduling becomes difficult. Like in the runtime, if every now and then I switch to process between process, then it is very difficult for us to understand and execute that which one is next, right? To put it into ready queue, suppose P1, P2, P3, P4 is all are present in the ready queue. Now at a particular time P2 goes off, so which one will be next? To decide this, we have this disadvantage in multi-programming OS, right? So this is our second one. Third one is the multitasking, or also another name is time sharing OS. Multitasking or time sharing OS. So what is this one? Multitasking means multi-programming but in a time slot. That means time sharing. So I will just explain. So what we have only one processor, right? Which is trying to execute n number of processes, right? So one processor doing context switch. Context switch means switching one process to the other. So one processor doing context switch between one process to other so fast that user does not have any idea that some work is idle in between. Like suppose if I have, suppose Word and email, all right? So these two are my work. Both are working via your OS through your CPU, right? So what is the concept of time sharing? When my Word is in action, at the same time I want to write an email, at the same time the switching process is so fast, the time slot is divided such that the switching process is so fast when the processor does not have any idea that what exactly is going on. Means the user will not understand that I am switching from one process to the other. It is like a same flow. The process has to load and work. Those concepts are not visualized by the user, right? So this is your multitasking OS. Fine. And the last concept that we have is the multi-processing OS. Multiprocessing means we have multiple processors. Multiple processors. Suppose this is my memory slot and I have CPU 1, CPU 2, CPU 3, CPU N. Right? So everyone is connected to a single memory for your data sharing, right? So there can be two types. One is symmetric, where one operating system is present which is controlling all the processors, and there is asymmetric, like distributed OS. I hope you have heard. So that is what here all processors are having different OS. Okay, but the common sharing is your memory, right? So asymmetric, you can give the symmetric, you can give the example of tightly coupled systems. Asymmetric, you can give it the example as the loosely coupled system. Okay, so multiprocessing means multiple processors are present. Now they can share data, they can have their own data which they can share. So anything can happen, like we can have the concept of distributed and networked OS, those things, but not that much complicated, but multiple operating systems, right? Okay, please repeat multitasking. Okay. Multitasking means when you have multi-programming environment. When you have multi-programming environment, but the time slot is divided between the work, so that when you are executing one word and when you are switching to other word, there is slightly no time gap as per the user's illusion, right? So only one CPU, but it switches between processes so quickly that it will give you the illusion that all executing processes are all processes are executing at the same time, but actually no, they have their time slots in which they will work, right? So that is multitasking. Fine. So next is these four names you must remember, right? So this is it. Now next we will move to the concept of system call. Okay, another important concept is system call. So again, I say that if you're noting down these points, you are likely to get questions, but mostly you will follow the book of Galvin for your concepts. Right, the book by Galvin, Operating System Concepts by Galvin. If you follow this, I think that will be clearing out all your doubts. Okay, so if you want in-depth knowledge. Now to understand system call, first let us understand the kernel mode and the user mode. See, some commands are present that you will use or in runtime your processor will need, which cannot be executed in user mode. Like suppose I want to use my secondary memory. So user cannot like use any command to execute that, right? So we have to go to kernel mode. Fine. So kernel mode you can say is a bit restricted for the system usage, and user mode is dedicated for our user, right? So what is the system call? Suppose I have 2 plus 2. I have to do this operation 2 plus 2, right? So this operation is done by processor simply. Who else can do it? Processor. Now, if we need to display, understand it, if we need to display our result, that is 4, on screen, then this displaying means what? I have to switch to my IO. Display means what? I will be using my monitor, right? So monitor means IO device. So I have to call IO. So who will call IO? Via OS, right? Or you can say via kernel, or you can say via kernel, because I'm interacting with the hardware, right? So via kernel. Now this can only be done using kernel mode. So you have to enter into kernel mode in order to show the result. To give the display, you have to call your kernel mode, right? Now for this type of activity, we require system call. So system call is a program, program, but in execution it becomes a process which has a lot of functions. Types of system calls are present, so I will discuss. If I call them, the kernel mode will do some work, right? So that is your system call. Fine. So just let us discuss the types. Means just understand, means know the name, so that if someone asks you, you are able to do. Read, write, general ones that are used, open, close. These four are the most utilized ones, so etc. I'm writing. So these are the most used ones, right? So system calls can be again be of two kinds of system call, two types. One is the device related system calls. Device related system calls means, suppose you have your, you want to go to your disk, like file control, you want to go to file control, or you want to go to IO control, right? So for that, we use the commands like IOCTL. I don't know how many of you know. This is used for IO control. So this system call is for IO control. We have file control. So CNTL. So this is for file control, or you can say storage control. So these are device related system call. Data related system call. Suppose you want to find out the situation of a particular process, right? So what the process is exactly doing. So what you need, you require PID. So you can write get PID, right? So by that you can understand the processes right now, what is the status, right? So this is your data related system call, okay? Now what data related system call is doing, it is extracting the metadata. Okay, what a process is doing means the process details, right? The PCB we will learn. So that means all the details about the process. So that is extracting the data about the data, right? So this is your data related system call. One very, very important system call is present that we use in multi-threading. So if we call about thread is what? When a process is divided into sub processes or subtasks which are not dependent upon each other or which can work independently, we call them as thread, right? So like your syllabus, we divide into modules and then finish, so that is thread. Some can be interrelated, majorly they are not, so that is thread, right? Now we have a fork system call. What it does, it helps in multi-threading. That means switching between the threads or executing threads simultaneously, right? So if we have a child and a parent process, like your concept of super and subclass, so this is initiated or this being used by the fork system call. So very important one, what is the purpose of your fork system calls? If we have multi-threading process, that is, we divide the process into child and parent process or n number of sub processes, then this order or the execution, or if it is working in multi-threading mode, that is controlled by fork system call, right? Next, other examples like for security part, data security, we have the control system call for changing the mode of files, so that is chmod. Okay, so there are numerous commands, numerous type of system calls. So just few ones I am telling you. So chmod. Next, for uh, communication purpose, like suppose I have some network, so network communication purpose, or like result of one is to be going to the other. So for those, we have this shared gate, pipe, these type of system calls. Right, so few names you can remember under each category, so that if it is being asked, or main question that can be asked to you is what is system call, or if you are able to answer, then what is fork, like fork system call is used for which purpose, right? So this can be asked. Fine. Now if we just go through a particular diagram of user and kernel mode, suppose this total big box is your total operating area, right? Fine. So here you have user mode, and here you have your kernel mode, right? So first the process execution starts, right? It will go for the system call. It is getting for the system call. Suppose it is the read operation or something, any system call. So it will go to the kernel mode, execute the system call. So read is being done, and here your output is being shown. So it is return output or result, whatever you want, from the process, right? So this portion execution is done in the kernel mode, and others are being done in the user mode, right? So this can go for display. So if it goes for display, again it will come to this execution of kernel mode, right? Or else if it goes for store, then no need of kernel mode, it can directly go and get the storage, right? So this is your means how a particular process works, right? So suppose you are into a bank, right? So there is a division of user and the bank personnel. So directly, if you want to withdraw money, suppose from a bank, so you write a receipt, how much money you require, and you give it to the personnel. Directly, do you jump into the locker room and get the money? No. So you have your own foundation, right? So kernel mode is the bank personnel, and user mode is yourself, right? So you can think the situation like that. Okay. Now next we will go to the process. Okay, up to this, whatever introduction and other things I have given, is it clear to all of you? Now I need the answer, yes, no. Whether it is clear to all of you, or if you have any question, then you may please ask. I will just take 2 minutes and try to understand whether you have understood everything or not. Tell me whether you have understood or not. Okay, fork and thread repeat. Yes, thread means, suppose there is a process. Now within that process, we have several instructions. Now, if we can just logically divide those instructions for execution, like if they are not having any dependency, they can work parallelly. For any process, if there is no dependency, suppose a transaction, they can work parallelly. So if they do not have any interdependency, then they can work parallelly. So that is your thread. So a process can be divided into multiple threads. So if you require that child parent execution, that is, one will call another and that will execute, or one will return some data to the other and it will execute. just like your super and subclass, then there you use the fourth concept, right? Network communication, I have not told it much. Network communication means if you want to share some file, like SHN get is the shared mode. All right, shared file exchange is this one. So there you can use this type of system call commands. Right, so that is what I have told. Network communication I have not told much. Right? Anything else? Okay. So next, before going into the process, just one concept more that we should discuss, that is spooling. Right? So spooling, if we go for the full form, then not exact full form, but some abbreviation of a concept: simultaneous peripheral operations online. Right. So just an abbreviation of this concept is spooling. So what happens? Suppose there is one resource which more than one process can access, right? So there, if one process is executing at a time, then the other process can also access. Like suppose your disk storage, right? So in your disk storage, your keyboard, mouse, scanner, or if I say printer, all are fetching data simultaneously via that disk. So that particular one, that this concept of working is spooling. So if I say, suppose job spool means nothing but just a queue where one by one process will be worked. So if I say the, we call it randomly, right? The printer spool, create the means clear the printer spool. Things are waiting, right? So suppose you are giving on print and the printer is not able to execute. So everything will be stored in a queue, right? So that concept is named as a spool, right? Suppose in terms of mainframes, when we are giving data for display, everything is getting stored in a spool, right? So we cannot say it's a concept of a hardware, but yes, the work that is being done like this. Like suppose if we just take, this is my input, sorry, this is just the input device, suppose. Input device, and this is my output device, right? If this is my computer, means this is my CPU and this is my memory, main memory, then input device is accessing the disk, that is the secondary storage, via your main memory. Directly it cannot. So it is giving and this is taking, right? At the same time, this can give the data to your main memory, give and take for some other processes also. So what happens here? The IO device, the input output devices are slower than your CPU speed, right? So main memory, that is cache. Main memory means RAM and ROM. RAM means nothing but a cache, right? So I hope you have these concepts because you have learned COA. Fine. So I will just assume that and proceed. So via main memory, all the communications are being done. Now, when the main memory is giving or taking data or something, it is also storing the data at the same time. That means The data is stored first into the disk and then CPU is interacting via the main memory. Fine. More than one input or output device is also accessing the disk simultaneously via main memory it is doing, right? Suppose main memory is fetching the value 2. At the same time, the output device is also requiring 2. So 2 can be displayed, right? So spooling is capable of overlapping some IO operations for one job from the CPU operation to the other job. Okay, so you can say the switching, right? So one is done, then you will go to the next one. So that can be done for spooling. So the storage is not related to the CPU here. CPU is not doing any storage. So this, after you do the storage, then via the main memory, CPU is interacting. Okay, so not only CPU is one example where we are using spooling, but for printers, scanners also we use the concept of spooling. Means we are creating a queue of storage, queue of display, anything we can do, right? So this is important. You have to understand and remember what do you mean by spooling. Okay, so when we are not directly doing a particular job, but for executing that job, now we require the concept of work, like it can be storage, it can be display, any type of work, right? So that is spooling. Fine. Now let us go into process. So in process, you have a lot of things, but I will only touch those areas from where you can get questions, right? So first is the concept of program to process to job. Now see, in some books you will find the term program, in some you will find process, in some you will find job. Now see, program is some just very static, it's a set of instructions. Process is something in execution. It can be a set of instruction, it can be one instruction at a time. That is a process. And there is no such difference between process and job. Normal systems that we use, there is no difference in process and job. So if I say process scheduling, if I say job scheduling, thing is more or less same, right? So if you take examples, we can take web browsers, execution. We can take word processors. We can say the email package, so on and so forth. So many examples are there. Okay, so program is the passive entity residing in your system, whereas the process is the active entity taking part in your processor, right? So if I take the example of a program, suppose Java program, right? So how do we execute? First we compile it with Java C, then we write Java says the program name, right? So I'm just writing it like that. So what Java, this command is doing? It is running the JVM. It is initiating your JVM where your program will exactly run. And what the program is doing? It is executing and returning the output to your JVM or the virtual machine, right? So what is a process? Any program, when you start executing it, it becomes a process. So the command that you are using, it is calling the environment. It is initiating the system call, right? So in this level, this, when you are executing a program, this is a very basic level, right? You are not using any software or anything. So at that level, this command of execution is your calling of the environment, that is the system call, right? And by the name of the program, you are justifying that what exactly you need to do, which instructions will be followed, right? So this is your process. Now, when we go to the states of the process, what are the states in which your process can exist? So when your program is just written and compiled, it is admitted for the processor. It can either run or it can wait for the IO or something, and then it can be terminated. Right, so how the communication goes? When the new process is admitted, if it has got no problem, then scheduled execution. If it gets some interrupt of IO, interrupt of file, anything, then it goes back to the ready state, right? Interrupt, it will not go to the ready state if it is having, suppose the interrupt of not execution or some other file is executing, suppose preemption that we call, if it has force stop, then it goes back to the ready state. And if it has got IO or anything, IO or any other peripheral like shortage, then it will go to the waiting state, right? So if I go to the peripheral release, then it will go back to the ready state. Fine. And finally, when the running state is done, it will exit from the processor and it will go to terminate, right? So this diagram may not be asked to you, but what are the states or which state has got what significance, that can be asked, right? So new, ready, running, waiting. The main problem is in ready, running, and waiting. So when it is ready, it is executing, then it is going to running state. If any other process is preempting it, then it goes back to the ready state. If it needs some IO or anything, it will go to the waiting state. And from waiting state, it will go to the ready state back and then again execute. And when all execution are done, it will go back to the terminated state. That is, it is exiting the CPU, it is releasing the processor. So it will go to the terminated state, right? Now, all these details about the processor, what is the process name, what are the IOs it required, for how much time it will execute, what are the peripherals it require, we maintain a data structure named as process control block. Very important. Only important things only I'm discussing, right? So process control block. So what is it? Every process is represented to the OS using one PCB, right? So every process to the OS, what is the representation? It is the PCB. PCB is the representation, right? So what are the things that are present in the PCB? First is the process state. State means the diagram that I have drawn. Ready, running, waiting, with what is the state that is represented. Next is the program counter. Program counter or PC, that is, what is the address of the next instruction? Suppose I am at instruction number 15. So what will be the execution of instruction number 16, or it will go to instruction number 19? Which one will follow? That is your program counter, right? Next, it will go to the processor registers. Register means the storage devices. Like we have accumulator register, we have the stack registers, those things, right? Sorry. So what registers are being used in this particular process, those will be written. Next is the scheduling information. Scheduling information means you will be learning that there are types of scheduling in a particular process. So what, under which category your process is falling, or that particular process P1 is supposed falling, that will be noted in each particular PCB, right? So if you have any priority or if you need any need of resource, right? So those things will be present in this particular processes PCB, right? Next is the memory, or you can say the storage. So how much address bits or addressing you require, what type of like read write operations do you require, those things will be given. Also the communication buses, so the communication buses involved, those will also be present in your PCB. Like every information related to a process, the process to be stored or to be executed, what are the things that we require, everything will be noted in the particular PCB with respect to that process, right? Next is the IO information, very important. Do you require any peripherals? Do you require any peripherals during your execution? Those will be noted, right? So that is present in your PCB, right? So PCB is nothing but a data structure maintained for one process. There will be one PCB, right? And what is there in PCB? These things: the state of the process, the program counter, the process register, and these things, okay? The IO devices, the memory, the scheduling information, the storage information, everything will be noted in the PCB of a particular process. Okay. Okay. So next we will learn is, if I have multiple processes to execute, if I have multiple processes to execute, then which process will be running when? This particular information is done by process scheduling, right? This process will be run by process scheduling. So next we will learn so if I have multiple processes in my ready queue, suppose P1, P2, P3, P4, 4 processes are present in my ready queue, means everyone is compiled and ready to be executed. So which one will be executed first, which one will be executed next, or based on any priority do I execute? What? Those decisions are taken by the operating system, your resource handler, or you say resource planner, anything, right? So the criteria for which we are doing the CPU scheduling is nothing but the CPU utilization, or you can say memory utilization. CPU utilization, right? To increase the CPU utilization, to increase the throughput. Throughput means what? What is a throughput? The number of processes that are completed per unit time. Number of processes that are completed per unit time. Maximum will be our goal, right? If I have 10 processes, we will say per unit time, every unit time one process must complete. So that will be our goal. Next is the process turnaround time. So these are our aim. Because of this, we will learn scheduling. Process turnaround time. What is turnaround time? The time when you submit your process to the processor, means you are writing everything and you are saving it, and you are then you are coming back and double clicking. That means you are submitting your process to the processor till the time of completion. That means in between, suppose it requires IO or it will go to the waiting state or something, everything will include in the turnaround time, right? So at beginning from the time of submission till the time of the output display. In between, if you have any, if you don't have anything, just you submit and the process is executed, fine. If you have IO waiting, if it goes for some other one is preempting it, then every time is calculated under the turnaround time. Okay. So it is the total time executed. Fine. Next is the waiting time and response time. Waiting time and response time, right? So what is waiting time? Suppose I have P1, P2, P1, P2, P3, P4, right? Suppose P1 is coming, doing its work. In between, P3 is coming. So P1 is waiting. Then P4 is coming. So P1 is still waiting. The summation of all waiting times that P1 is undergoing for completion. After this, suppose P1 is getting the chance to complete. Execution time, no. Only the waiting times that P1 is undergoing. The summation of periods that P1 is undergoing to wait in a particular process execution, it is named as the waiting time. So suppose you say that P1 is waiting and then P3 is starting, then again P1 is means executing, then again P4 is coming and starting its work. So P1 to P3 10 seconds, then again P1 to P4 another 10 seconds. So the total after that P1 is executing and completing. So this 10 seconds plus the next 10 seconds, so total 20 seconds P1 is waiting. So that is the waiting time of P1. Right? In a lifetime of new to terminated, how much time it is waiting? Summation of everyone is the waiting time of the process. Next is the response time. Response time means, suppose I have a particular process that gives me 10 outputs. Fine. Now, the time of submission of the job and the first output shown on the display. 10 outputs will be shown, right? The first output shown in the display, this gap is named for the response time. Suppose after the first display, the process is again going into ready state. After 5 seconds, again it is giving me the outcome. So that is not my response time. That is my turnaround time, total completion of all 10 results. But what is my response time? When it is getting submitted and the first instance when it is showing me output. This particular time interval is named as the response time. Okay. So CPU utilization must be maximum, throughput must be maximum. What is throughput? The average number of processes that are getting submitted or that are getting its output successfully per unit time is the throughput of your system. Next one is the turnaround time. What is the turnaround time? When you submit the process and the process execution is totally completed, the total time in between, suppose you have waiting, you have IO, you have preemption, these things. So involving everyone, the time for the last output is your turnaround. Okay, from the submission till the last output. And what is response time? If you have multiple outputs, then the instance of first output from the time of job submission is your response time, right? So difference between turnaround time and response time will only evolve when you have multiple outputs. If you have multiple outputs, then only your response time is lesser than the turnaround time, because turnaround time means all outputs displayed, right? And what is waiting time? If your process is going for wait state, suppose one time in its lifetime, or 2 times, 3 times, 4 times, n number of times, the summation of all waiting times that the process is going in its lifetime, it is your waiting time. Fine. So our process scheduling is to improve everything, like waiting time must be reduced, response time should be increased, turnaround time should be increased, throughput should be increased, and utilization must be increased, right? So these are the goals or the criteria for CPU schedule. Next, we will learn the most famous scheduling algos. And I will just show you each with one example. So the first one is scheduling first one, first come, first serve. Very, very simple algo. First come, first serve. So what is being done in this one? Suppose I have what will be like given criteria, the process names and their burst time. Burst time means total time in which it should execute. Like suppose if I say P1 is of 10 seconds, that means for 10 seconds P1 will be in execution, right? So suppose I have P1, P2, P3, and this is suppose 20, 5 and 7. So I will take the arrival time like P1, then P2, then P3, right? Or else you can also take the arrival time, right? But that is not required in FCFS. The order that is given in which they will execute. So it will start from 0 till 20. P1 will execute, then 20 to 25, P2 will execute, and then 25 plus 7, that is 32. P3 will execute. So this is FCF. It's very simple. All the jobs that are submitted based on their order of receiving in the ready queue, they will get executed. There is no preemption. This is a non-preemptive process, and once a process is taken, it will be totally done. Next process will start, right? FCFS. Next one, shortest job first. Shortest job first. So it can be of two types. One is non-preemptive and one is preemptive. Non-preemptive means once a process is starting, other processes cannot forcefully stop it. And preemptive means once a process is ongoing, other processes can stop it, and they can also execute for some time, and then again next one will start, right? So first let us discuss the non-preemptive one, shortest job first. So at a given point of time, the job which is shortest in time span, burst time, it will get executed. So process and the burst time. It's a non-preemptive, right? So P1, P2, P3, P4. Suppose 6, 8, 7, 2. Right? So first, non-preemptive means no one can forcefully stop it. So the one who will start will finish. So shortest job among them is, what is the shortest of these? 2. So P4 will start, which is next 6, right? So P1 up to 6 seconds or 6 unit of time. Then P3, right? Then P2, 23, right? So shortest job first, non-preemptive. Shortest job first means the one having the lowest burst time will execute first. So here, if it is non-preemptive, then when which one is arriving, I don't have any problem in that. So at a time, the one which is having the lowest burst time will start, and then likewise, like you can say ascending order of work. Okay, and there is no forceful stop, right? So next one we will see the forceful stop. So let us see the preemptive example. Process and burst time. Here we need the arrival time, or else how do we judge the preemption, right? So arrival time. So suppose I have P1, P2, P3, P4. Arrival time is 0, 1, 2, 3. This is 8, this is 4, this is 9, this is 5. Suppose one example, right? So At the, who will start with? Now, who can tell me from which one we will start? From which one we will start? Who can tell me? In this situation, which one we will start? Anyone else? With which one we will start? In this preemptive process, with which one we will start? P1, right? So why? Because at the time instance 0, only P1 is existing, others are not, right? But after arrival time 1, the P2 is coming into the picture where the burst time is lesser than P1. Means at the 0th level, I will start with P1, but at the 1 level, I have my P2, which is having burst time 4, right? Which is lesser than P1. So this is becoming 7 because one portion has been executed. This is my 1. This is my 0. Understand this very well. At 0th level, only P1 was existing. So I have started with P1. But as soon as 1 unit of time is occurred, my P2 is coming into picture, which is having lesser burst time than P1. So it will be taken up. Now see, at the second arrival time, that is 2, my P3 is coming, but it is having 9. So shortest job is home. This is my shortest job. At 3, 5 is coming, but that is also greater than 4. So what will happen? P2 will get executed for 4 unit of time. And at this stage, I have 2, I have 3. That means P3 has arrived, P4 has arrived. So P4 is having 5, P3 is having 9, and P1 is having 7. So at this point of time, I have P1, P3, and P4. P2 is already done. So among P1, P2, and P4, P1 was having 7, P3 is having 9, and P4 is having 5. So which one will execute? P4. So P4 will be executing till 10. At this time, again, I have P1 and P3. P1 is having 7 and P3 is having 9. So which one will execute? 7. And then you have your P3. That will long till 9. So 17, then 26. Right? So if I have a preemptive process, this is how we will handle. First, the 0th one or the lowest time framed one will start. It will continue up to the next one arrives. When the next one arrives, we will keep on checking that whether their burst time is lesser than that or not. If yes, then we will give the chance to them. Like here, P2 has overcome P1, right? And then after that, P3 and P4 are arriving, but they are having greater burst time than P2, right? So let us finish P2 first. So P2 is done. Then we will go for P1, sorry, P4, because P4 is having the next greatest burst time, 5. After that, we will go for P1, which is having 7 burst time, and last is P3, that is having 9 burst time, right? So this is your SJF. Next one you have is the priority scheduling. Next one you have is the priority scheduling. What is the priority scheduling? Here, along with the process name, your priority will be given and the burst time will be given. Right? Priority will be given and the burst time will be given. So what is, means what do we need to do here? This one, suppose P1, P2, P3, P4. Priority is, suppose let us jumble up 3, 1, 4, 5, 10, 1, 2, 1. Suppose I have P5. So priority is 2 and the burst time is suppose 5, right? So who is having the lowest priority? P2 and P4, right? Both are having priority. Sorry, this is your burst time. Who is having the lowest priority? This one, right? So we will start with P2. Now, P2's burst time is just 1, right? So we will start with, fine. Next is priority 2, P5 has come. Who is having burst time? So 6, then P1 is having 3, so 9, then P3, sorry, this is not 9, this is 10, and likewise. So this is also a non-preemptive one, right? So if you have preemptive one, then again another column will be added, that will be your arrival time. So again you have to check at suppose 0th time who are present in your ready queue, at 1th position who are present in the ready queue, and likewise you have to preempt your processes, right? Last one, that is round robin. What is this? Round robin scheduling. What is this? Time slice is given as suppose 4, and the process will be given and the burst time will be given, right? So suppose P1, P2, P3. This is having 10, this is having 7, and this is having 3, suppose. So first I will start with P1 up to time slice, that is 4, P1 will work. So P1 is remaining with 6. Then P2 will work. Is it greater than 4? Yes. So 4 is utilized, that means 8. Then P3 will work. P3 is lesser than 3. So P3 will work till 11. Then again I will go to P1. So P1 will work for another 4 time slice. Next P2 will complete. And then P1 will complete. At 20, P1 will complete. So this is your round robin. Time slice will be given and every process will be used, or every process will be using the particular time slice, right? You can say at a particular time event, time slice, whether do you have more than that burst time or less than that. If you have more than that burst time, then execute and hold the remaining. Likewise, once all the processes are done, then again we will start from 1. Right, so this is your round robin. So there ends your CPU, or you can say the process scheduling. We have 4 categories under which FCFS does not have any preemption or anything. SJF has, priority has. So you may just go through them. Like problems, they may not ask you to solve, but concepts they can ask you. So there you can give an example and solve, right? So next step we will start with process synchronization, right? Synchronization and deadlock. So in synchronization, you have mutex and semaphore. You have your dining philosopher problem, reader writer problem, producer consumer problem. So I will just write the algorithm for them, that how they are actually working, and I will explain. Okay. So today I will end the class over here, and who will be taking the next class, that is 2 to 3:30, which subject will be taught, that we will be giving in your group. Okay, in your Telegram channel only we will give, right? Okay, so if you have any more questions, you can put forward, or any topic that you want me to cover, then that also you can put forward, so that we can discuss it in tomorrow's class. Those who don't have any questions or anything to discuss, you may leave, You can again rejoin at 2. Yes, round robin, I will explain. In round robin, a particular time slot will be given. Time slice, we call it, given. Right. So the number of processes will be given, their burst times will be given. So first we will start with one process. Is the burst time greater than the time slice? If no, then it will be done within the time slice. If yes, then only the time slice period it will execute, and then it will context switch to the next process. Next process will execute. Again, if it is greater, then it will context switch to the next one. If the next one is lesser than the time slice, it will execute totally. Again, it will context switch to the first process. Likewise, every process will get same time slice to execute one after the other. Right? So this is round robin. I hope that's okay. Okay. Okay, so if you don't have any more questions, then we can leave this class here. Okay, so thank you. See you in your next class.